Welcome to The Explainer. So, today we're embarking on a massive, centuries-long journey. We're tracking the evolution of the machine that literally built our modern world, the internal combustion engine. From its incredibly messy, frankly explosive beginnings, all the way to the hyper-refined power plants we have today, it's just an unbelievable story of sheer human ingenuity. Let's get into it.
Okay, think about your morning commute for just a second. You get in your car, you push your button or maybe turn a key, and instantly this smooth, reliable engine hums to life. And we completely take it for granted, right? But how on earth did we actually get here? Like, how did we go from ancient Chinese fire arrows fueled by black powder in the 10th century all the way to the sleek, ultra-reliable sports cars on the road today? Well, the journey between those 2 points is packed with chaotic, explosive, and honestly pretty dangerous experiments by early inventors who were just trying to somehow harness the raw power of combustion.
So to make sense of this massive history, we've broken this explainer down into 6 distinct eras. First up, sparks and early experiments. Then we'll move into the atmospheric engine era, followed by the monumental four-stroke revolution. After that, we're taking to the skies, looking at the modern performance engine, and finally, we'll wrap up by examining the future of combustion.
Section 1. Sparks and Early Experiments, the Wild West of Combustion.
Okay, let's dive into this. The early days of combustion were truly the Wild West of engineering. I mean, way before anyone even conceptualized gasoline or diesel, inventors were just struggling to figure out how to safely contain an explosion. Look at 1678. Christiaan Huygens was literally trying to use a gunpowder explosion inside a cylinder just to create a vacuum. Fast forward a century to the 1780s, and you have the chemist Alessandro Volta. He created an electric pistol that used an electric spark to ignite hydrogen gas. This was absolutely crucial because it proved a spark could safely ignite fuel. And then, by 1807, François Isaac de Rivaz actually managed to fit a hydrogen-fueled spark-ignition engine to a crude four-wheeled carriage. It's wild. They were grappling with the absolute basics of controlled explosions long before liquid fuels were ever the standard.
And speaking of 1807, you really have to appreciate the sheer audacity of the Niépce brothers over in France. They actually powered a boat up a river using an engine called the Pyréolophore. And guess what the fuel was for this pioneering aquatic journey? Controlled dust explosions. Seriously. Just imagine pitching that to investors today. Oh yeah, we're going to propel this wooden boat by deliberately blowing up highly combustible dust inside of it. I mean, it's absurd, it's terrifying, and yet, incredibly, it actually worked.
Section 2. The atmospheric engine era, harnessing the explosion. So, moving into the mid-19th century, the challenge shifted. It wasn't just about making an explosion anymore. It was about doing useful, commercial work with those explosions. Now, to understand this era, we need to clarify a crucial piece of mechanical jargon, the atmospheric engine. What is it? Well, in these early designs, the explosion of gas inside the cylinder didn't actively push the piston to do the main work. Instead, the combustion created a vacuum. Then, normal atmospheric pressure from outside the engine would push the piston down into that vacuum. It was a really clever workaround, but crucially, it completely lacked in-cylinder compression. The fuel and air were just drawn in and ignited at normal everyday pressure.
Now, what's really interesting here is how two heavyweight engines battled for dominance in the 1860s. Etienne Lenoir's 1860 engine was a massive milestone. It actually saw commercial use in Paris. The problem? It guzzled fuel at a completely alarming rate. Enter Eugen Langen and Nikolaus Otto. Just 4 years later, they built their own atmospheric engine. By totally optimizing the mechanics, they managed to cut the Lenoir engine's fuel consumption by more than half. That was a huge deal, and it rightfully won them a gold medal at the 1867 Paris exhibition.
Section 3. The Four-Stroke Revolution, the Golden Age of Invention.
The atmospheric engine was really just a stepping stone taking us into the late 19th century. But as we know, progress is rarely a smooth ride. Before Nikolaus Otto completely changed the world, he experienced some pretty catastrophic failures. In 1862, he built an early prototype attempting a four-stroke cycle. And the result? Well, the engine ran for just a few minutes before it literally shook itself to pieces and self-destructed. Boom. He actually had to walk away from the whole four-stroke idea for over a decade before finally conquering it. And this illustrates that massive breakthrough when Otto finally nailed it in 1876 with the Otto silent engine. On the left, you've got the old atmospheric logic, right? Draw fuel in, ignite it at normal pressure.
Simple enough, but look at the right side. This is Otto's new logic. You draw the fuel mixture in, and then you use the piston to compress it really tightly before the spark ignites it. That in-cylinder compression, it was a total game changer. It resulted in a vastly more powerful and efficient explosion. It was such a massive leap in mechanical engineering that it completely rendered those old atmospheric engines obsolete almost overnight.
And the incredible innovations just kept coming. While Otto was using a spark to ignite his compressed fuel, another German engineer, Rudolf Diesel, had a totally different theory brewing in the 1890s. He realized something fascinating. If you compress air hard enough and fast enough, it generates immense heat. So, if you inject fuel into that superheated, highly compressed air, it just ignites spontaneously. No spark plug required. Absolutely brilliant. By 1897, Diesel had a working prototype of the very first compression ignition engine, which forever changed heavy industry.
So with this massive flurry of innovation, this new engine technology finally found its wheels. In 1885 alone, Carl Benz built the patent Motorwagen, which is widely considered the very first automobile, and Gottlieb Daimler built the first motorcycle, powered by his high-speed grandfather clock engine. Then, just a few years later in 1889, Wilhelm Maybach built the very first V engine. Just like that, the automobile industry had officially been born.
Section 4. Taking to the skies, speed, and flight. Okay, so the internal combustion engine had conquered the roads, but humanity? We wanted to go higher and faster. Just look at this rapid-fire progression as we hit the 20th century. By 1902, we already have the very first V8 engine being bolted into early French airplanes. Fast forward to 1926, Robert Goddard launches the first liquid propellant rocket. Just 4 years after that, Frank Whittle patents the concept of a turbojet. By 1939, the Germans are literally flying the first jet aircraft, the Henkel Hay 178. And by 1941, the Italians are already strapping afterburners onto their aircraft for extreme thrust. This relentless, unyielding quest for extreme power and altitude drove combustion technology to its absolute physical limits.
But you know, amidst all this intense focus on jets and rockets, there was actually still room for some radical innovation back down on the ground. In 1957, a German engineer named Felix Wankel built an engine that completely threw away the traditional up and down pistons. The Wankel, or rotary engine, uses this eccentric triangular rotor spinning inside an oval chamber. It's a really famous, high-revving departure from standard reciprocating engines, and it proved that even after a century, the basic geometry of combustion could still be completely reinvented.
Section 5. The modern performance engine, refinement and complexity.
Entering the late 20th century, the basic architecture of the engine was pretty much set in stone, so the focus shifted entirely to high-tech refinement. It was all about squeezing every single drop of performance. In the 80s, Isuzu was out there experimenting with ceramic engine blocks to retain heat and cut fuel consumption. In 1989, Honda completely changes the game with VTEC, using computers to adjust valve timing on the fly for better performance. Moving into the 90s, mechanical carburetors are basically phased out for ultra-precise electronic fuel injection, and Toyota starts using literal lasers to clad their valve seats. No way, right? Lasers. And by 2017, Infiniti achieves the absolute holy grail, an engine that can dynamically alter its own compression ratio while you're driving. Every single ounce of efficiency was being squeezed out through just brilliant material science and computer engineering.
Which brings us to this specific, absolutely staggering number, 55. In 2017, Ashadis Power showcased a reciprocating engine that achieved a maximum brake thermal efficiency of 55%. To put that into perspective for a second, early engines wasted the vast majority of their fuel's energy just as heat rather than actual motion. So turning 55% of that energy into usable mechanical work, that is an absolute, undeniable modern marvel of thermodynamics.
Section 6. The future of combustion. Sunset of an era.
But, you know, all eras must eventually come to a close. And there's a real irony here. Just as the internal combustion engine has reached its absolute technological zenith, it now faces a global phasing out. At the COP26 conference back in 2021, 24 countries officially committed to banning the sale of new petrol and diesel cars by 2040 to fight global emissions. Major automakers are following suit. Like Hyundai, in 2022 announced they've actively stopped developing new combustion engines, shifting all their engineering focus over to electric vehicles. Now, some companies, like GAC Group, are experimenting with alternative zero-carbon fuels like ammonia, which is fascinating. But the traditional century-long gasoline and diesel era is very clearly drawing to a close. Which leaves us with this final, lingering thought for today's explainer. As the world fully commits to a zero-emission future by 2040, how will history ultimately judge the legacy of this brilliant, explosive machine? I mean, this is a technology that emerged from chaotic, dangerous gunpowder experiments, got refined by absolute mechanical geniuses, and ultimately went on to shrink our globe, take us to the very edge of the skies, and literally build the modern industrial world. It is, without a doubt, one of the most important machines ever devised. Thanks so much for joining me on this journey, and keep learning.